Right, looks good.
Excellent. All right. Thanks for having me. We discussed quite a bit in the panel before, and you probably heard it from many of the other speakers and panelists that the last year has seen an incredible transformation from kind of like a more offline world to a digital world and to e-commerce. And like a journey that we thought would take many years was compressed into just a few months. And I think we have seen this in terms of the expectation that customers have for everything to be delivered faster and to be more seamless, but also the actual experience when people use your e-commerce site. They just expect the search to work like Google. They expect the speed. They expect it just to be a very seamless experience. And just from my own experience as well, shopping more online, being at home with like 2-year-old twins, buying a lot of baby clothes, and all of that is more tedious than it should be. And I think just a little bit selfishly, we're looking to change this. And today I'm going to talk to you about how to unlock revenue using AI search and discovery. And unlocking revenue in this case means also making my life easier and making me convert to it. So my name is Jens Schumacher. I'm the Chief Product Officer at Sajari. Just real quick about Sajari. We are a search platform, and we enable, like, our mission is to enable every organization to create smart search experiences. So as I mentioned, we provide an AI-powered site search and discovery platform. We do around 2 billion API requests per month. And in the last year alone, we have seen the query growth or the search growth increase by 350%. And we power the e-commerce platforms or the search on those platforms for a number of large companies around the world. Now, one interesting stat that is highly relevant here is that 45% of online transactions happen via on-site search. So people actually go there and type something into the search box that leads them to purchase something. And then a lot of the other experiences, the discovery experience, where you go to a category page or like a what's new page, that also delivers somewhat of a search experience. It's a more curated search experience, sometimes merchandise, but oftentimes powered actually by the same technology. So you can create a more holistic experience. Now, the other data points is the conversion rate itself. So here we can see that Amazon has like a 15% conversion rate, Walmart has a 6% conversion rate, and Target as well. And the industry average is actually quite lower at 3.3%. So Amazon, just in this chart, has 5 times the conversion rate of the industry average. And search is actually a critical part to this, and Amazon knows that. And that's why Amazon actually has a team of 1,500 people. I hear it's actually more now, that exclusively work on search for them. That's not around the e-commerce platform or the store. That's a technical team that just works on search. So the question is, how many people do you have on your search team, if you have a search team in the first place? Yeah. And you're not alone. It's not that like most companies actually don't have a large search team or a dedicated search team even. And we've seen this in a lot of the online experiences. So this is an example from Lacoste. They actually fixed it since. This is probably like a half year ago, they probably fixed it. But when you went to Lacoste last year and looked for a polo shirt, you actually didn't find any results. And Lacoste is quite famous for the polo shirts. So you can imagine how much this failure in delivering a relevant result here actually cost them. Like, what did they miss out in terms of sales because of this? So also related to kind of relevance, and we come back to that in a second, is position bias. So one great quote that I found on the internet is that the best place to hide a dead body is page 2 of Google search results. And the relevancy here is that it actually matters quite a bit where your search results appear in the ranking, because there's an inherent position bias. So it's not just in regards to page 2 of the search result, but even on page 1, based on the data from our customers, we can see that actually the position of a search result matters immensely on how people perceive it. They just believe that the first result is probably the best, the second result is gets a lot less clicks, and the third result's a lot less. Now, that's the position bias just in the result. But what ultimately determines whether somebody clicks on a product or on a particular result is actually the position bias combined with the relevancy. So if the first product is actually not the most relevant, but it's the first product, it still has like a relatively high chance of being clicked on. But the problem is that if you don't match the position bias with the relevancy, in other words, if the highest relevant product is not number one, you're actually missing out on conversion rates. Let me demonstrate this on just the first line here. So if we're looking at the chance of interaction here for the first result, the position bias accounts for 10% and relevancy for 50. So that in 10 times 50% gives us in total the interaction likelihood of 5%. Yeah. Now, if we actually increase the relevancy and match the relevancy to the position bias here from 50 to 80%, that upgrades this by 3% to 8% of total, right? Now, that gives you an idea, like a 3% difference on whether somebody clicks on a particular product in a particular position makes a big difference. So if you align those two and actually align the position bias with the improved relevance, you can make a massive improvement to the overall probability that somebody actually clicks through and purchases a product in the end. Now, how do you do this? How do you actually get to better relevance? And for that, we're going to talk about two machine learning topics today. And I'm going to keep them quite simple because obviously the technical mathematical parts underneath are pretty complicated, but in general, actually, machine learning is not that hard to understand, even though it always sounds a little bit like magic. So I want to cover two topics today. The first one is called reinforcement learning, and the second one is neural hashes. Starting with reinforcement learning. And so essentially boiled down, reinforcement learning simply means that there's a system that learns from interactions that your users or your customers make with your website. So is it purchases or adding products to a cart or just clicking on search results, like recording those interactions and learning from the user behavior and what they feel is relevant and what they end up purchasing. Yeah, let's take, for example, a search for shirts. So we have a number of results coming up, and we see somebody doesn't buy the first one, not the second one, not the third one. They end up buying the fourth shirt. Like that's kind of the most relevant to them. Yeah. So what reinforcement learning does now, it basically captures that intent and captures that purchase and adds it to a particular model that in the background learns which products are the most popular for this particular query. So for a particular query, for this shirt query, we keep track of what are the products that are most often purchased. And even if the text relevance, like the exact text matching or some other parameters rank other products higher, the reinforcement learning basically says, yes, you determined that this product should be higher, but actually the user behavior says otherwise. And over time, it just bubbles up the products that really should be on the top because most people find them to be the most relevant, or those are the ones that are purchased. And then you see the next time somebody searches for shirt, you actually see that product being bubbled up. Now it's in position 3 instead of position 4, and it slowly works itself up. Yeah. So that's a really simple example on how you track the particular queries matching particular products. But this can also be used to improve the relevance of an overall search and categories. So one example that we run into a lot in marketplaces that provide in particular like a broad set of products is that the same search can have kind of different meanings. So take, for example, a search for TV. So here you see there's actually a few TVs on the search result, but you also see accessories for TVs. So those match generally because they have TV in the title or TV in the description. And also there's often an emphasis on how often was a product purchased, or the margins if they're high. So that would also bubble them up. But actually, if somebody searches for TV, they probably don't want to buy like a flat panel cable holder, right? They're probably looking for TV, and that's what you want to sell them. So what you can do here is actually you look at the products that get purchased and the categories where the products come from. So in this case, we capture that search for TV. In most cases, people actually end up purchasing an actual TV instead of an accessory. Yeah, so in this case, we just say 88% of the time somebody ends up purchasing a TV instead of an accessory. Now, what we can do now is we actually weigh that and say, well, because everything 88% is the dominant category, so we boost the products that come from this category. Yeah, and accessories are going to get deprioritized on this search. So, and that will then change next time when somebody searches for TV, you actually just show TVs. And this is an automatic way to change what usually is done by manual rules. And I get to manual rules in a bit, but if usually you fix this manually when somebody searches for TV, then show us actual TVs. But there's all those edge cases. If somebody searches for OLED TV or HD TV, did you have them all covered, and do you have all those rules specified? So really having machine learning dictating or specifying what are the most popular products for a particular category and doing it automatically has huge advantages over doing it manually in a rule-based environment. Yeah. So that's reinforcement learning, basically just understanding the customer behavior, looking at the customer behavior, building a model, and then boosting those products accordingly. Now, the second area is even more interesting, and that's neural hashes. And before we talk about neural hashes, we probably should look at the evolution of search for a second. So really, most search engines that are being used today are keyword-based. And the keyword-based technologies have been around since the 90s. So like when I started working on searches, probably was like the early 2000s, and the technology was around for a while. And it's usually simple keyword-based search matching. So if the keyword appears in a title or in a description, it gets a certain weight. And it works all right, like especially if you have a lot of rules in place, you can make it work. And it's generally fast. So that's kind of why it's still popular. But it's also very limited because it doesn't really understand what you're looking for. It only understands, does this keyword match a keyword that you have in your product catalog? And then the next phase started in like 2013 and is still going on, and that's vector search. Vectors is basically a way to represent terminology. I'll explain it in a second in more detail. And it's kind of the first step into an AI search, understanding the meaning of search, or understanding the relevancy, or how different terminologies or even images are related. The problem with vectors is that it works usually quite well, but it's very slow and very hard to scale to large data sets. And this is what brings us to neural hashes. So the idea is still similar to vectors, but it's a different way to represent the data and store the data that is much more efficient and also scales much faster. So it allows us to create a very, very fast search across a large catalog of data. Now, let me come back to the problem real quick. So let's assume that we search for a sweatshirt, and this is our keyword search, which requires a pretty much almost exact match. I say almost because it does handle things like sweatshirts, like multiples, or sometimes spelling mistakes. There's technologies to do this, but generally it requires a match of this particular keyword. Unless you have manual rules specified, like I mentioned for the TV. So in sweatshirt, you also might want to match like a pullover or a jumper or a sweater, right? So those are all synonyms. And what you end up with, and this is like a live example, is a huge catalog of, so you end up with a huge list of rules that have to be created and manually maintained. And the main problem for those rules is that they also start to impact each other once you have a lot of rules set up. So let's say for the category rule, if you say, if somebody searches for TV and you want to show them, and you want to make sure that they only see items from the TV, you have to put a hard rule in it, but you don't know if that affects something else. And the same is true for synonyms as well. So it gets a bit out of control and gets really hard to maintain. And at some stage, it's really hard to improve your conversion rate further because you have so much data that you have to worry about and that interacts with each other. Now, with vector relevance, you take that word sweatshirt and you put it into a vector space. So in this case, it's displayed as a two-dimensional space. It's actually a lot more dimensions, and it's a mathematical representation of this data. But essentially what it does, it looks at the proximity of specific terms. So in this space, you have sweatshirt and pullover and jumper pretty close to each other, and mathematically you can calculate the distance between them. And basically what it does then, it knows that these are all closely related items. The same is true for trousers and jeans and chinos down there. They're all kind of pants. And you can, if somebody searches for trousers, you know, it's like, hey, they're looking for pants. So even if we don't have trousers, maybe they're interested in jeans or chinos. Yeah. So you don't have to have an exact match anymore. You can use the similarity that is represented in those vectors and surface results based on that information. So now with that data, we can then go and search for sweatshirts. Usually we would have just gotten the exact matches, but with the vector search, we also get an additional product here that matches pullover in the title, and it doesn't have sweatshirt at all anywhere in the description. So this saves you a ton of time, in particular if you have a really large store. You don't want to maintain manually all the rules and the synonyms. Now, those two combined, the learning with the vector search becomes even more powerful. Yeah, and so what we do, we actually looking at combining all the even keywords has good aspects to it as well. So figuring out how do you combine all the best parts from the different technologies, that's how you achieve the best results, and just experimenting and see what's best for your business. Yeah. But to summarize, the first thing is that relevance is probably the most important lever that you have to maximize online conversions. And like the two aspects in terms of the machine learning capabilities are just a couple of examples on how to improve relevance. There's a whole other topic around personalization and making sure that you have a user journey that goes from somebody gets an email promoting a particular product, then coming back to the website and making sure that personalization that we just done for email is also reflected in the search experience or the product discovery, and we're promoting the same product or the same categories there as well, and having a holistic user journey. Yeah, or making sure that we have the right product at the right time. Like I gave in the panel earlier the example of a face mask. If you searched for a face mask in 2019, you probably looked for a beauty product. If you're searching for a face mask in 2020, it's quite different. And having the relevancy adapt with the machine learning, with the machine learning capabilities automatically adapting to the different user behavior, that is pretty invaluable. The second one is that machine learning actually helps you to level the playing field. So you have Amazon and Google and Target, they have huge search teams. But the technology that they use actually has become more widely available. It just has to be like implemented and made accessible and optimized for e-commerce search. And this is what's starting to happen now. Yeah, so that's what we're looking to do. Like our goal is really to enable every company to provide a great search experience and leveling that playing field. And the technology is really a massive enabler to make that happen. And then lastly, you don't actually need to hire 1,500 people in order to provide a great search experience. You just leverage the technology that I just talked about, and it can help you to provide a better customer experience and ultimately unlock additional revenue. And that already concludes my presentation. So I think we have some time for questions. So if you have any questions, I would love to hear them and answer them.
All right. If you have any questions for Jens, you may send them over to the chats or the Q&A tab on the right-hand side. So Jens, for the interest of time, if you have any questions for Jens, you can just send him a private message, or you can visit Jens over at the Sajari booth. Jens will be there together with his colleagues to answer any of your inquiries. Thanks, Jens.
Okay, thank you.